Welcome to the Deep Dive. Today we're going right into a really in-depth look at chemical muscle enhancement.
Yeah, it's a big topic, and our source for this is, well, it's pretty unique.
It is. It's a text drawing from over 20 years of direct experience, research, and even personal experimentation in bodybuilding and sports enhancement.
Right, hands-on stuff. And the author does give a heads up. Some of the language, the terms used might be a bit direct or sensitive for some listeners. Just be aware of that.
Good point. And what really stands out is the author's background, martial arts, powerlifting, and biochemistry. Quite a mix.
That's what makes it compelling, I think. That blend of practical application and the scientific understanding behind it. It's not just theory.
Exactly. It feels grounded. So for you, the learner, our aim today is to really unpack how these different chemicals are understood to affect muscle growth, fat loss, physique, all based strictly on this one source.
And we're staying objective here. It's about understanding the ideas the author presents, not pushing any particular view, especially on, sensitive topics.
Absolutely. Just the facts as presented in the source. Okay, let's jump in. The author's starting point is interesting frustration with supplement ads.
Yeah, that really kicked things off. Seeing all the hype, the crazy promises in magazines, and deciding, okay, I need to figure this out for real.
And that led to this deep dive into training, nutrition, and anabolic androgenic steroids, race.
But what's really striking, and the author highlights this, is managing to pack on 95 pounds of lean muscle in 30 months without Teresa initially.
That's incredible. It just shows how much knowledge about training and nutrition alone can achieve, doesn't it?
It really underscores that foundation. Doesn't matter what path someone takes later, that base knowledge is, fundamental.
Right. Then they moved into professional training, sports rehab, even research for supplement companies.
Only to find, maybe unsurprisingly, that the industry often seemed more focused on cheap ingredients than what actually worked best.
Yeah, a bit disillusioning, it sounds like. But the driving force behind all this seems to be a real passion, describing the human body as an expression of art.
That passion comes through. So they've built this impressive physique naturally, seeing the supplement world from the inside. Now let's get into the core principles they lay out. Anabolism, catabolism.
The building up and breaking down. These are central.
Absolutely. The author explained anabolic hormones are like the on switch for growth. They mention PTOR, while catabolic hormones are the off switch, causing breakdown.
And the body's always trying to balance these. Homeostasis?
Exactly. Always seeking that balance. And what's really insightful is the point about reducing catabolism. They theorize a 50% reduction could potentially lead to significant muscle gain in a year for an average person, even without boosting anabolism directly.
Wow.
Yeah.
That really shifts the focus, doesn't it? We're always thinking build, build, build.
Right, but preventing the breakdown is just as critical, maybe more so in some ways.
And weight training, of course, affects both sides. You stimulate growth, but you also cause some breakdown. Overtraining is when that breakdown side wins out.
Precisely. And the source mentions studies suggesting maybe 80% of the growth signal from training gets canceled out by catabolism, leaves you with just that 20% difference.
Which explains why progress can feel so slow sometimes.
And why people hit plateaus, right? You reach a point where building up just equals breaking down again, a new balance.
That makes total sense. So understanding this balance, it explains the logic behind why some athletes might turn to chemical enhancement.
That's the rationale presented, yeah. Trying to tip that balance firmly towards anabolism or maybe strongly inhibit catabolism to push past natural limits.
It's about influencing those fundamental processes. The author shares personal experiences and observations too, framing it within the context of individual health choices like alcohol or tobacco.
Kind of drawing a parallel there, but again, we need to stress this is just reporting on the source's perspective and information, not an endorsement.
Definitely. Okay, let's get more specific. Hormones. We've got estrogens and androgens. What are the key distinctions according to the text?
Pretty straightforward distinction made. Estrogens, estradiol, estrone, progesterone mainly drive female characteristics. Androgens, testosterone being the big one, but also others like androstenedione drive male characteristics. Deeper voice, muscle mass, bone density, that sort of thing.
And for males, testosterone is the main player. How's it actually made?
Well, Males produce much more, obviously, because of the testes. The source mentions the adrenal glands chip in a bit, making some prohormones alongside adrenaline.
But the main factory is the testes, specifically Leydig cells.
That's right. Leydig cells in the testes are the primary production site for testosterone.
And this production isn't just random, it's regulated, the HPTA axis.
Yeah, the hypothalamus-pituitary-testes axis. It's a feedback loop. Hypothalamus releases LHRH, tells the pituitary to release LH and FSH, which then signal the Leydig cells.
And the levels of testosterone circulating then tell the hypothalamus and pituitary to, like, slow down or speed up.
Exactly. It's a self-regulating system trying to maintain balance.
Got it. So testosterone is key, made in the testes, regulated by the HPTA. But androgens do more than just affect testosterone levels themselves, right? The secondary stuff.
Oh, yeah. The source lists things like sexual behavior, libido, penis development, body hair, voice deepening, aggressiveness, sperm maturation, even acne due to sebaceous gland activity.
It's a wide range of effects. Now, how do these steroids, natural or synthetic AAS, actually work inside the muscle cells?
Okay, this is where it gets down to the nitty-gritty. Testosterone in the blood is either bound to proteins like SHBG or it's free. Steroid molecules, both the body's own and AS, can interact with SHBG, maybe changing that free-bound ratio.
And the free stuff is what matters for getting into the cell.
Well, the key is the molecule finding its specific androgen receptor site on the muscle cell. It's like a lock and key mechanism.
Okay, key in the lock, then what?
That steroid receptor complex travels into the cell's nucleus. There, it binds to the DNA.
To the actual genetic material.
Yep. And that binding triggers transcription, basically, copying a specific part of the DNA code onto messenger RNA or mRNA.
Okay, so a message is created.
Exactly. That mRNA message then leaves the nucleus, goes out into the main part of the cell, the cytoplasm, and undergoes translation. That's the process where the cell actually builds new proteins based on the mRNA instructions.
More protein synthesis equals muscle growth.
That's the main anabolic effect. Plus, the source mentions testosterone can also block cortisol receptors. Cortisol is catabolic, breaks muscle down, so blocking it reduces breakdown.
Ah, so it's a double whammy, building more and breaking down less. Makes sense. Now, all this building needs energy, ATP and phosphocreatine.
Absolutely fundamental. ATP is the direct fuel for muscle contractions. When it's used, it becomes ADP. Phosphocreatine, or CP, is crucial for quickly turning that ADP back into ATP.
So more CP means you can work harder for longer?
Essentially, yes.
Yeah.
Increases work capacity. And the author points out the old idea that CP only boosted strength, not size, was wrong. We saw that proven when creatine supplements hit the market.
Right. And more CP also pulls more glycogen and protein into the cell, making it bigger.
Yeah, it contributes to cell volumization, similar in effect to IAS in that regard. So CP isn't just about immediate energy, it impacts cell size too.
Okay. So after the testosterone, or AAS molecule, delivers its message at the receptor, what happens to it? It doesn't just vanish, right?
No, it goes back into the bloodstream. It might bind to another receptor somewhere else, or it gets metabolized, broken down by enzymes.
Broken down into what?
Could be converted into other compounds like estrogen or DHT dihydrotestosterone, or into inactive forms that the body can then excrete.
DHT sounds important. It binds better to the receptor?
It has a higher affinity, yeah.
Yeah.
Generally considered more androgenic than testosterone, but often less directly anabolic in muscle tissue itself.
And DHT is linked to things like acne and hair loss.
That's right, because it binds strongly to receptors in sebaceous glands and hair follicles, also the prostate. But the source does note positives for DHT too, like muscle hardness and the fact it can't convert to estrogen.
Interesting trade-offs. And eventually, all these steroid molecules end up processed by the liver and removed.
Ultimately, yes. The liver metabolizes them for excretion.
Okay, so we've got the cellular action. Now, when muscles get bigger from this, is it just the existing cells swelling up, or can you actually make new muscle cells? Hypertrophy versus hyperplasia.
Good question. The author tackles this, debunking the old idea that Charius gains were just water. They state it's real tissue changes, which is why you lose size and strength when you stop.
Makes sense. So, two mechanisms.
Right. Hypertrophy is the main one, individual muscle cells getting bigger. That's the primary effect of androgens A driving protein synthesis. But hyperplasia, creating entirely new muscle cells or fibers, is also possible.
And Charius can accelerate that too. Because of all the protein synthesis and let's breakdown.
That's the idea. And interestingly, the source notes that even years of intense natural training can lead to some new fiber growth. So the highly anabolic environment from TRS could really give hyperplasia a boost for long-term potential.
Right. And maybe steroids that are more anabolic than androgenic lead to better keeping those gains afterwards.
That's suggested, yeah. Better lean mass retention post-cycle. Which leads us nicely into the different types, oral versus injectable steroids.
Yeah, they aren't all created equal, are they?
Definitely not. Both types can be altered chemically to change that anabolic to androgenic ratio. Injectable testosterone itself is generally seen as highly androgenic and anabolic.
But then you have things like nandrolones.
Exactly, like DICA. Those are nortestosterones, created by modifying testosterone to be more anabolic and less androgenic.
And the side effects. Is it just about how androgenic something is?
That plays a part, certainly. Higher androgenicity and a higher potential to convert to estrogen or aromatize are often correlated with more side effects. But the author really emphasizes that estrogen conversion itself and how that impacts the HPTA feedback loop is a major factor in side effects.
That's complicated. The dream would be something totally anabolic, no androgenic effects, no conversion, no side effects at all.
That's the theoretical holy grail, yeah. Pure muscle growth with no downsides. Doesn't exist, of course.
Right. Okay, the source goes into a lot of specific compounds. Let's touch on some key ones. Oxymethylone, anadrol 50. Sounds potent.
Extremely. Oral, highly androgenic, highly anabolic. Known for rapid weight gain, the text mentions reports of up to 20 pounds in 3 weeks.
Wow. Strengths and recovery, too.
Big increases reported, also aggression, which could be good or bad depending on focus, and significant water retention, leading to that big muscular look. Often used off-season for mass.
But the downsides sound serious.
Very. The author calls it potentially the most dangerous AS if abused, linked to severe issues, liver problems, even cancer, heart disorders, plus the common stuff like hair loss, prostate enlargement, shutting down natural hormones.
Yikes. Okay, what about methyl testosterone, another oral?
Yeah, also oral, highly androgenic, but has a really short active life, like 6-8 hours. Also liver toxic because it's C17 alpha alkylated.
And it converts to estrogen easily.
And more easily than injectable testosterone, apparently, due to liver enzyme activity. So initial weight gain is often mostly water. You might feel stronger quickly, but gains are short-term. High blood pressure, nosebleeds, aggression. The author doesn't really see much use for it in bodybuilding.
Doesn't sound appealing. Now, oxandrolone anavar, that one often gets called milder, right? All-purpose.
It does have that reputation. The source highlights something unique. It seems to stimulate phosphocreatine synthesis really well, better than others. So faster ATP regeneration, rapid strength gains.
And less baggage, like water retention or estrogen conversion.
Right. Users report distinct muscle hardness with little weight gain and no aromatization. Good for pre-contest hardness. And because it's low androgenic, it was originally made for women and children, minimizing virilization risks at lower doses.
Interesting. Now, are there ways people try to get around the liver issue with orals? The source mentions DMSO and vitamin E oil.
Yeah, these are methods described. DMSO is a solvent. The idea is it helps carry the steroid through the skin. Another reported technique is crushing oral tabs like primobolan, mixing with vitamin E oil and swallowing it. The theory is it gets absorbed via the lymphatic system, bypassing the liver initially, similar to andriol.
Sort of like trying to find loopholes in the body's processing. Okay, moving to injectables again. Nortestosterones, the nandrolones, like DECA, generally more anabolic.
That's the profile. Highly anabolic, moderately androgenic. Considered protein-sparing, relatively liver-friendly, according to the literature cited.
And the reported positives.
Significant lean gains, often described as high quality and slow building, good retention after stopping, low to moderate water retention, low conversion to estrogen, actually more estrogen, doesn't seem to hammer HDL cholesterol badly. Also mentioned are benefits for joints, protein sparing, maybe even inhibiting fat synthesis and boosting metabolism slightly.
Sounds like a solid profile.
Yeah.
And different versions exist, like Anador and Loroborn, just longer-acting versions.
Essentially, yeah. Anador is long-acting, similar results to DECA, needs high protein intake. Lorobolan is even longer-acting, both known for slow, steady, retainable lean mass gains. Less worry about DHT side effects like prostate issues.
Okay. Then there's Finaplex trenbolone acetate. This is the one from animal implants.
That's the one. Originally cattle implants. The source describes various, frankly, risky methods people apparently use: crushing and swallowing, dissolving in oil for injection, which raises huge sterility questions.
Injecting something meant for cows dissolved in oil doesn't sound wise.
Definitely not. Topical use with DMSO is also mentioned, even using the actual implant guns on humans, which sounds incredibly painful. And they debunk myths about rectal absorption.
Oh, wow. Okay, quickly. Metribolone.
Injectable, short active life, known for acne, very liver toxic, low water retention, no estrogen conversion.
Got it. Now, moving beyond the actual AAs, what about supporting compounds? HCG, human chorionic gonadotropin, what's its role?
HCG mimics LH, luteinizing hormone. Medically, it's used for fertility. In bodybuilding, it's used to stimulate the testes, the Leydig cells, to produce testosterone again.
So when HCG shuts down your natural production,
HCG can help kickstart it. Studies show it can significantly boost plasma testosterone. It's used mid-cycle sometimes, or more often post-cycle, to combat testicular shrinkage and restore function.
so it directly stimulates the testes. What about Clomid, clomiphene, and cyclophenol? They work differently.
Yeah, they act higher up on the hypothalamus and pituitary to restore the entire regulatory HPTA axis. HCG just bypasses the upper parts and hits the testes directly.
And Clomid also acts as an anti-estrogen.
Kind of. It's a synthetic estrogen, but it blocks the receptors from stronger estrogen, so less gyno, less water retention. Not as strong as Nolvadex for that, but helpful post-cycle for recovery. Cyclophenol is mentioned too. Some used it with prohormones, reportedly lowered estrogen and boosted testosterone, but there's a concern about estrogen rebound when stopping it.
Managing estrogen seems key post-cycle, which brings us to specific anti-estrogens. Nolvadex, Proviron, Teslac.
Right. Nolvadex blocks receptors, doesn't stop production, so stopping it can cause issues. Proviron is interesting. It's an androgen itself, used post-cycle to provide some androgenic effect while natural production recovers, boost libido, and potentially reduce circulating estrogen slightly. Doesn't fix the root cause, though.
And Teslac. That sounds different again.
Teslac, testolactone, is an aromatase inhibitor. It actually stops the enzyme that converts androgens to estrogen, so it prevents gyno, water retention, etc. It's technically a very weak oral steroid itself, considered the best anti-estrogen by the author for males, and it can even help boost natural testosterone by influencing the HPTA.
So different ways to tackle estrogen, blocking receptors versus stopping production. Then there are diuretics, used for that pre-contest dry look.
Exactly, but the source heavily emphasizes the dangers. Messing with electrolytes, dehydration can be fatal.
Different types mentioned.
Yeah, potassium-sparing ones like aldactone, thiazides, and loop diuretics like Lasix. Lasix is the really potent, fast-acting one. Extremely dangerous if misused, acts within hours. Used right before a show for that super ripped look. Banned by IFBB, of course.
And glycerol is mentioned too, another fluid manipulation tactic.
Yeah, and the source gets into the importance of managing sodium and the hormone aldosterone to control subcutaneous water, including strategies like salt loading weeks out from a contest. It's a complex game with high stakes.
Definitely sounds risky. Okay, shifting gears. Thyroid hormones.
Easy.
T3, T4, used for fat loss.
Primarily, yes. Used during calorie restriction to boost metabolism, increase thermogenesis heat production, and burn more fat. They can also potentially enhance the effects of other compounds like AS and GH.
Needs careful management. High protein intake to avoid muscle loss.
Absolutely. Minimum 2 grams protein per pound body weight recommended in the source to prevent catabolism. And it really stresses these should only be used under medical supervision. There are risks, side effects, and suppression of natural thyroid function.
The source mentions natural production, how T4 converts to T3, and things like Coleus forscoli or Triacana as maybe milder options.
Right. Coleus forscoli is an herb reported to stimulate the thyroid. Triacana is considered a safer thyroid drug that doesn't push metabolism quite as high. But still, caution is urged.
Okay. What about human growth hormone GH? That's a big one.
Huge! Naturally produced by the pituitary. The source mentions the history cadaver-derived GH causing problems. Now synthetic versions are standard.
And the main desired effects.
3 key ones. Increased fat burning, especially when glucose is low. Potent anabolic effects building tissue, protein synthesis, and importantly, it can potentially cause hyperplasia, new muscle cell formation, which is permanent. Plus, it helps build connective tissues. And third, it's a powerful anti-catabolic, helps hold on to muscle when dieting.
Sounds like a potent combination, often used with insulin.
Yes, insulin is another major hormone discussed. Produced by the pancreas, its main job is controlling blood sugar and storing nutrients like carbs, fats, amino acids, and cells.
Athletes use it to force nutrients into muscles faster. especially post-workout.
That's the idea. Enhance nutrient uptake. The source gives examples of cycles combining insulin with GH, T3, even oxandrolone. But it strongly emphasizes the danger you must consume enough carbs, at least 10 grams per IU of insulin, to avoid potentially fatal hypoglycemia.
Very risky if not managed perfectly. What about metformin or rosiglitazone related to insulin?
Yeah, metformin is a diabetes drug that increases insulin sensitivity. Rosiglitazone is mentioned for potentially improving the muscle-to-fat ratio long-term, again through better insulin sensitivity.
And IGF-1, insulin-like growth factor 1, connected to GH.
Yes, it's produced mainly in the liver when GH acts, and insulin plays a role too. Muscle tissue can also produce it locally after intense training. It has receptors everywhere and is considered extremely anabolic, maybe even more than GH or insulin.
Wow. Okay, quick mention of oxytocin, not typical bodybuilding stuff.
No, mainly known for roles in bonding and orgasm. The source includes it with a strong warning about misuse causing severe cramping and other issues, strictly for qualified personnel.
Gotcha. What about prostaglandins? Local signaling molecules.
Yeah, intercellular messengers, needed for anabolic substances to fully trigger protein synthesis. Levels of some prostaglandins, like PGF2, seem to rise alongside reduced catabolism. Intense training, especially negatives or stretch position exercises, triggers their release in the muscle.
So they're part of the muscle's response to training stress.
Seems that way. And things like cortisol inhibit them. COX2 inhibitors might also interfere.
TNF tumor necrosis factor. Sounds bad.
Usually part of the immune response. Can kill fat cells, which sounds good, but it can also kill muscle cells, not really a targeted physique tool.
Right. Clenbuterol. Not a steroid, but used a lot.
It's a beta agonist. Not directly anabolic, but it's anti-catabolic. It slows protein breakdown more than it slows synthesis. Also boosts thermogenesis for fat loss, often stacked with thyroid or cortisol inhibitors. But effectiveness fades as receptors downregulate.
People use ketotefin for that downregulation.
Yeah, it's reported to help maintain receptor sensitivity, though drowsiness is a common side effect.
Okay, DNP-2-4-dinitrophenol. The source sounds extremely cautious here.
Extremely. It makes energy production incredibly inefficient, uncoupling oxidative phosphorylation. Metabolic rate skyrockets, body temp rises. It's literally described as chemical exercise, but incredibly dangerous. High doses can cook organs.
Even if a thermometer doesn't show a high temp.
Right, because the body tries hard to shed heat. The real danger is cellular ATP depletion. The author shares their personal cautious usage rules, tiny doses, timing, hydration, short cycles, very risky stuff. Notes it might clean out androgen receptors too.
Definitely not for casual consideration. New Bane. The painkiller. Any merit to the bodybuilding claims?
Dan Duchesne speculated it might be anti-cortisol or lipolytic. The author here disagrees, sees no benefit outside pain relief, notes addiction potential and its likely discontinuation. Mentions a withdrawal protocol using Ultram.
So mostly debunked. Finasteride, Proscar? The hair loss drug, how does it fit in?
It stops testosterone converting to DHT. Good for preventing hair loss from androgenic steroids. Some report reduced libido or less physique hardness, though. Libido might be less issue if using other androgens.
Okay, site injections. Injecting synthol or Protest directly into muscles.
Yeah, the theory is it stretches the fascia, creates space for growth. Author describes it more like encapsulated oil pockets, creating localized size. Synthol is the known one, inert oil. Protest is mentioned as a gray market, posing oil that actually contained prohormones and testosterol, showing significant testosterone boosts.
So it's not just oil, it's delivering active compounds directly.
Yeah.
And the source gives max mix examples.
Yes, examples combining various areas with these site enhancers for targeted growth. Sounds extreme.
Definitely. Now, libido, urges often increases it initially.
Yeah, due to elevated androgens stimulating receptors in the brain, increasing nerve sensitivity. But then receptors can adjust, and post-cycle, when natural levels are low and a receptor is desensitized, you often get a crash.
Worse with stronger androgens.
The source suggests the fall from high androgenics is tougher on libido than from milder anabolics. Duration and aromatization play roles, too.
And psychologically, coming off, seeing size decrease must be tough.
The source briefly touches on that potential difficulty, the imminent shrinking fear.
And monitoring all this requires blood tests.
Absolutely essential, the author stresses. Especially with orals, monitoring liver, kidneys, heart function is crucial. Blood counts, thyroid levels. Regular tests help manage risks and optimize results. But interpreting them needs context. Results mean different things in heavily training athletes versus sedentary people.
Right, and underpinning all this chemical strategy is nutrition.
Paramount. More important than anything, the author says. They detail asking clients for extensive logs, workouts, foods, supplements, meds.
General macros suggested.
For mass gain and non-obese clients, roughly 30-40% protein, 40-50% carbs, 20% fats, maybe higher protein if prone to fat storage. High protein itself can aid fat loss due to its thermic effect.
Protein intake levels.
Minimum 1 gram per pound body weight daily, often 1.5 to 2.5 grams per pound for serious athletes aiming for growth. Nitrogen balance is key.
And absorption matters, not just what you eat.
Big point. Chewing food properly, enzyme production. It all affects how much protein you actually use. Undigested food hinders growth. Blender shakes are suggested for hard gainers.
Whey protein types. Ultrafiltered versus ion exchange.
Yeah, pros and cons. Ultrafiltration keeps more beneficial fractions. Ion exchange gives higher protein percentage but might lose some fractions. Mimicking mother's milk ratio, more whey than casein by mixing powders is mentioned, but whole food sources are still primary.
And the myth about only absorbing 30-gram protein per meal.
Debunked. No solid research supports that limit according to the source. 30-60 gram per meal shake is fine.
Carbohydrates. Important for glycogen.
Crucial for recovery and fueling workouts. Lower glycemic index carbs, yams, oats, brown rice, veggies are generally preferred for steadier insulin and better glycogen storage. Alternating carb sources might help manage fat.
Fat loss requires specific strategies, mentioned for later discussion. Okay, lastly, supplemental creatine.
Revisited here, how it's made in the body, transported to muscles, converted to phosphocreatine, CP, to regenerate ATT. The importance of loading phases to quickly saturate muscles is emphasized. Maintenance dosing alone isn't as effective for reaching hyperconcentration.
And it pulls water into cells, the osmotic effect.
Yes, cell volumization, similar to Maris in that way, increases intracellular nutrients. Loading with high glycemic carbs helps achieve the needed concentration faster.
And things that help or hinder creatine transport.
Sodium and insulin help transport it. Clenbuterol, T3, IGF-1 can upregulate transporters. High caffeine doses and soy isoflavones might inhibit it.
Lots of factors. And the source references scientific journals throughout.
Yeah, brief mentions indicating some of the info draws from published research, adding that layer of scientific grounding.
So wrapping this up, we've really covered a massive amount of ground, looking at hormones, training, nutrition, and a whole host of chemicals, all through the lens of this one very detailed source.
It's incredibly complex, isn't it? The sheer number of substances discussed, the intricate mechanisms, the potential interactions. It really paints a picture of a deep, long-term exploration by the author.
And for you, the learner, hopefully this deep dive gave you a thorough, albeit condensed, look into the ideas and the reported effects laid out in this text.
And just to reiterate one last time, this was us reporting on the content of the source material. It's absolutely not an endorsement or recommendation of any of these practices.
Critically important distinction, which leads to a final thought. Maybe. Given everything we've discussed, the potential gains, the significant risks, the body's own incredible complexity, what does enhancement really mean?
Yeah, and where does someone draw the line for themselves in pursuing physical goals? Considering all these factors, it's a really profound question to reflect on.
Definitely food for thought. Thank you for taking this deep dive with us today. Let us know what other topics or sources you'd like us to explore in the future.